welcome again for the second CICS session of the day. Stuart's here from Hursley to talk about CICS Java application development for everyone, even me. So without further ado, Stu, take it away. I shall go on mute now. If anyone's got any questions, just pop them in the chat because you're all on mute. Cheers.
Great, thanks, Rob. So a little bit about me. I'm Stu. If you don't know me, I have been working on CICS Explorer for about 12 years now. I'm the lead developer on CICS Explorer, and I've also been responsible for leading the development of some of our developer experience initiatives. And part of that has been looking at what we can do to make the Java application development experience for CICS more relevant to the existing Java experts in the industry who don't necessarily have specific CICS experience. So looking at how we can take advantage of the skill set of existing Java developers. So I'm going to talk to you a bit today about what we've delivered in the last year and a half. So this is all, broadly speaking, this is all CICS TS 5.6 content, but there is some supporting tooling that's available that's applicable to all releases of CICS. We're going to talk about all of that stuff. So one of the great strengths of CICS as an application server is it's amazing at hosting polyglot applications. So that's applications where they can have different components written in different languages. And it is really interesting how for an application in CICS, you can seamlessly move between these different languages, and the CICS API makes that kind of magic happen for you. And you can pick for each component the language that's best suited to the problem that you're trying to solve. So it makes it really easy for, I mean, I have a Java background and made it really easy for me to pick up extending CICS applications with some Java component by using the CICS APIs available to do that. So I kind of mentioned there that it gives you the opportunity to pick the language that's best suited to the problem that you're trying to solve. Java gives you some really interesting options around that. CICS provides JVMs with really tight integration with native applications, so you can write a Java application that's an extension of your existing CICS application that's able to participate in the same business transaction. So it'll get committed or backed out together. So it'll be a completely natural extension of what you already have. The API you can use in Java applications to interact with your CICS resources and link to other programs is called JCICS, and that's been around for quite a long time now. And in any of the JVMs that you set up that run managed by CICS, the CICS Java API JCICS will be available in those. And that's essentially a Java analog of the exec-CICS API. So a lot of the things you can do with the exec-CICS API, you can do with JCICS API. So reading from TSQs and linking to programs and reading from files and stuff like that. So when you deploy your applications into CICS, there's a few different ways you can package your Java application to deploy them. We support deploying OSGI bundles, which is an enterprise kind of service container for a Java application, or you can deploy applications that are written against the Java EE standard for web specification for web applications. So that is a really good way to specify how you want to do kind of web services as Java programs. One of the environments we provide, which has really good integration with CICS, is WebSphere Liberty Profile. So Liberty Profile, you may know as a flavor of WebSphere application server. It was released quite a few years ago now, but it is essentially a streamlined version. So it has a lot of the kind of content is minimized so that it has fast startup, and you can pick the components of the application server that you want to run. It's designed to run Java web applications that are written to the Java EE specification. So that's what the environment that we use in CICS to deploy those. When you package an application to the Java EE spec, when you deploy it into CICS, you can deploy it into a managed version of WebSphere Liberty Profile. And again, that has really great CICS integration. So we'll manage running your work on a CICS task and stuff like that as appropriate. So when you get a request coming into the web server, we'll bind that to a CICS task. It can run as part of the same transaction as anything it links to, so you get the same kind of commit and rollback behavior. So WebSphere Liberty Profile, or WAS itself, provides all these different capabilities particularly of the Java EE spec. So you get these technologies like servlets, JCICS, WebSockets, and now things like microprofile, which provide this set of capabilities that it might previously been very difficult for you to augment your application with. Things like WebSockets are really interesting. So being able to do asynchronous communication between an application running in CICS and a client application running either in someone's a rich client application on the desktop or a web browser or something like that, being able to have your application server message the client directly. Those sorts of capabilities are something that's very natural for Liberty, but very difficult to implement if you don't have a framework like Liberty to rely on. So Java in the industry is obviously really popular. I have a couple of supporting graphs that demonstrate that. The chart on the left is from 2018 and the chart on the right is from 2020. So this is pretty current. The left-hand chart is from Cloud Foundry's developer survey. So I think they actually survey people who are making IT purchasing decisions for this survey. And they are asking which languages they use in their applications. And this is the top part of the table. So these are the most used languages in their enterprise. So this is things like Java, JavaScript, C++, and C#. And you can see that Java and JavaScript were the two most popular, and that was from 2018. On the right-hand side, this is a slightly different survey. So this is a developer survey by a company called RedMonk. And actually, sorry, it's not a survey. What they did is they did some analysis where they looked at projects on GitHub. And if you've been on GitHub, you'll see that it tags all of the repositories with the language that the application in that repository is written in. So this is a scatter plot of the popularity rank on GitHub on the x-axis along the bottom. And on the y-axis up the side, it's the popularity rank on Stack Overflow. So Stack Overflow, the popular question and answer site for software engineers. So all the answers on there get tagged as well. So this is a chart. If a project is tagged on GitHub with Java and a question is tagged on Stack Overflow with Java, you'll kind of get high on the x-axis, high on the y-axis. And you can see, if you look in the top right-hand corner, there's Java, JavaScript, Python, C# and C++. So it kind of correlates with the chart on the left-hand side, but that's just to demonstrate kind of the popularity of JavaScript in the software development ecosystem. Sorry, of Java, not JavaScript. So our existing toolchain we have for working with Java applications in CICS relies heavily on the use of CICS Explorer. So this is a few little shots of what it looks like in CICS Explorer when you're working on a Java application. I've been working on CICS Explorer for the last 12 years, as I said earlier. So I am pretty proud of the experience we can deliver in CICS Explorer because we're able to rely on something like Eclipse. That means we can build on the Java development experience you already get in that environment. So Eclipse is the framework that CICS Explorer is built on. Eclipse kind of cut its teeth as a Java development environment, which means that CICS Explorer can lean on all the capability that Eclipse delivers for Java development environment. We augment that with some additional behavior to be able to do the CICS specific bits that you need to in Java that you can't do with vanilla Eclipse. So part of that is taking that JCICS API that you have available in CICS, making that available in your development environment so you can compile your Java applications against it. And another part of that is being able to author CICS bundles. So that's the kind of wrapping package unit for deploying applications into CICS, in particular Java applications. You can put a variety of things in a CICS bundle, but CICS bundle is the way for delivering Java applications into CICS. So why do we need CICS bundles? So a CICS bundle is, as I said, a packaging entity for deploying resources into CICS. It provides a way, kind of a handle for CICS. So that's the way we register a bunch of different components all together so that we can lifecycle them as one entity within CICS. So typically what I'm going to show in some examples later is we'll be using a CICS bundle to wrap one Java application. You can put a whole variety of different things in a CICS bundle and then manage all those resources as one thing. So you can put Java applications in there and file definitions, transaction definitions, policies, event bindings. You can put a collection of different resources inside a CICS bundle, and then you can enable them all together, disable them all together, and discard them all together. So you can manage that collection of resources as one entity within CICS. The other important role that a CICS bundle plays when we're deploying Java applications is it provides a way of telling CICS the additional information that it needs to be able to deploy that application. So CICS is capable, each CICS region is capable of hosting multiple JVM servers. So that's multiple Java virtual machines. And when we deploy a Java application into CICS, we need to tell it, when we deploy the bundle into a particular CICS region, we need to tell it within that CICS region, it could be any of a variety of JVM servers, we need to tell it which one it's going to get deployed into. So the CICS bundle provides a way of supplying that metadata. So on the right-hand side here, you can see I've got this snippet of XML, and that tells us the name of the CICS, of the application we're deploying and which JVM it's going to go into within our CICS region. So it's important in our tool chain for when we're authoring applications in Java and we want to deploy them into CICS that we have some way of providing this information so that when we deploy the bundle, it knows where to go. So CICS Explorer is great at doing its job if you are happy to learn a new tool like CICS Explorer, but it does enforce a tooling choice for you. So, and it also enforces a choice of environment for you as well. If you choose to use CICS, if you are using CICS Explorer, then you have to be using one of the supported releases of Eclipse that we're on, and you have to be then kind of by extension, you have to be using Eclipse for your development tooling. And also because of the way we take applications and package them, we want to, because of the way that we take your applications and package them in a CICS bundle, we make kind of assertions about the way you're going to be building those applications as well. And it turns out that that doesn't necessarily best reflect the trends in the industry around the best way to build Java applications. So I'm going to talk a bit about some build systems that are used for actually building Java applications. So the two most popular of those are called Maven and Gradle. Maven and Gradle are both pluggable build systems for Java applications, and they form two roles. The first part of the role they perform is dependency management, and the second part of the role they form is pluggable build systems. So I'm going to talk a bit about dependency management first. So if you are writing a Java application, when I first started writing Java applications, when I wanted to use a third-party library like something like Apache Commons, the way you would get that into your environment, I would first have started using Eclipse. I would go to the Apache website, find the version of Apache Commons that I'd like to use, and then put it in a lib folder. And then when you run your Java compiler, you'd add that lib folder to your class path. And that would mean that when you compiled your Java application, it would be able to reference those classes and everything would compile successfully. So the way Maven and Gradle work is a bit different. So there's an online catalog of libraries instead, which is called Maven Central, and that has more than 3 million different reusable components. So there's multiple versions of each component as well. So you don't just get the latest version of each component, you get all the versions that have ever existed of that component. So this example here I've got on the right-hand side is showing you the different versions that are available of Apache Commons Lang 3. And the way Maven and Gradle work is instead of going and downloading those libraries directly, you reference that library and you say, I would like, my application depends on this, this Java library from Maven Central. And the way you reference it is a combination of 3 strings, which is a group ID, an artifact ID, and a version. And together they make what everyone refers to as coordinates. And when you run Maven and Gradle, they are actually responsible for going and downloading that for you. So they have a local cache, And if it's not available in your local cache, that will go off to Maven Central, or you can host that internally if you don't want them to contact a public update site. So there are ways of doing repository mirroring, which means you can have a whitelisted set of dependencies that you have cleared to be used for applications within your organization. So Maven and Gradle will be responsible for going to a remote repository and retrieving the library and adding it to your class path and invoking the compiler. So you just declare a dependency and they handle the rest for you, which is, I remember the first time I heard about Maven and Gradle, it was kind of interesting. I was kind of not sure I wanted something else to be responsible for downloading libraries for me. But Maven and Gradle are incredibly popular within the industry. And I have some charts on that as well, which I can show you to kind of demonstrate that. So the first thing I talked about was how Maven and Gradle are good for dependency management. I also want to talk a bit about the pluggable build system aspect of that. So the other part of both Maven and Gradle is that so they're responsible for running the compiler and putting things on the class path for you and running, say, the jar command to package your classes up into a jar file. They're also really good at extending that process, so you can write an extension to a Maven build and then package that as a library. And the really cool thing is you can take that library and you can publish that library to Maven Central as well, or your own internal repository. And then other people can use that build extension in their builds as well. And the nice thing about that is you publish it to exactly the same repository as all your application dependencies go to. So all of the build extensions also go to Maven Central and use the same coordinate system for that as well. So you refer to your build extensions by group ID, artifact ID, and version as well. And then that's for Maven. For Gradle, it's slightly different, but the build tool will be responsible for downloading the build extensions from the same repository as it's getting its libraries from as well, which is really neat. So it's a kind of built-in way of distributing custom build logic as well, which can be otherwise difficult. So how popular are Maven and Gradle? This is from the SNCC Java Ecosystem Report in 2018. So I think if I was going to say that anything had changed in the last 2 years, it would be that Gradle would be more popular. This is looking at the technologies that people use to build their Java applications. You can see that pretty much between them, Maven and Gradle cover most the vast majority of Java application builds. I think Gradle's popularity is probably rising in part because it is the recommended build tool for building Android applications. So anyone who's building applications from that platform will be using Gradle. So part of what we wanted to look at was how Maven and Gradle, because they're so popular, how easy is it to use Maven and Gradle to build CICS applications? And it turned out that it's not very smooth. So the CICS Java API that I talked about, JCICS, is or was not available on Maven Central. So I know that from talking to a lot of people, they were having to take the JCICS jar, which is com.ibm.cics.server.jar is its name. They're having to take that and then rehost that. So for customers who were looking to use technologies like Maven and Gradle, they're having to run an internal repository and then find the JCICS jar in their CICS installation, then upload it to their internal repository so that their developers had access to it in their Maven builds locally at local compile time. We built all this bespoke support in CICS Explorer for automatically setting up a compilation environment. So we'll do things like add the server jar to the class path for you in your development environment. But if you're using Maven and Gradle, they're going to be responsible for managing the class path in a completely different way. So that doesn't go very well. You can't use kind of both of those technologies together. I did mention in Explorer, once you actually have the dependency set up on the class path using our existing technology stack, the experience is actually pretty good. We get to lean on Eclipse. It's a full-fledged Java IDE, so you get that rich experience there, and that all works quite well. But it does mean that you have to use CICS Explorer to do that without being able to use things like Maven and Gradle to build your Java applications. So, and also you have to deal with that bit on the end where you take your Java application and you wrap it up in a CICS bundle. So what have we done to address this? So the first thing we did was pretty straightforward. We took our Java API libraries, so that was JCICS, but there's other parts as well. So there's the annotations that we use for things like link to liberty and the annotation processor that you can use in your build to make that work. They're all available in Maven Central now, and we did that for CICS 5.6 all the way back to CICS 5.2. And you can find, you'll see as an example, this is how you declare a dependency on the right-hand side. This is how you declare a dependency with Maven. And you can see that we put all the independent APAR versions of those libraries out there as well. So if you need a very specific version, all of those are available on Maven Central, and that's kind of an automatic part of our build process now. So you can use those libraries for either your Maven or Gradle builds. So both so the repository is called Maven Central, but it is the repository that's shared between Maven and Gradle as a source of libraries. So you can use those versions that are in Maven Central, regardless of whether you're using Maven or Gradle. And then we wrote a couple of build extensions for Maven and Gradle to make it so that you can have a Java application build, and you can add a build extension which will take that Java application and wrap it in a CICS bundle so that you can publish it to your CICS region, so to make that process easier. So I'm going to show you a bit about what it looks like when you're using, so I'm going to demonstrate Maven running in Eclipse. I'm going to show you what it looks like when we're developing a little CICS Java application. This is what it looks like. So we have a backend program called accounts, and we have a front end. This is kind of what we're going to do is we're going to API enable that backend application. So this is a dummy program which is going to serve up account information. So we have a servlet. In our servlet, we're going to link to that program using the JCICS API, using channels and containers. We're going to pass the account number in via a container called account number, and then the backend program is going to respond with the balance for that account in an account balance container. And then our servlet's going to serve the response as a JSON document. So we could conceivably use that in a front end web application or something like that. So I'm going to switch over to Eclipse now. So let me talk a little bit about the setup I have here. So in my Project Explorer here, you can see the source for my Java application. It doesn't currently compile. That's why I have these red crosses here and the red underlines down here. This is the servlet part of the application. So this is going to be responsible for handling an incoming web request and serving up a JSON document. The web request will be able to specify the account number, and the response will show the balance for that account in a JSON document. So Liberty makes that really easy to do the response bit. We just tell it that it's going to produce application JSON, and it will handle the serialization for us. Then we're using the JCICS API here, creating a task, getting the current task, creating a program, set the name to the backend program that we're going to link to. Then we take this account number from the input here. So we're going to be able to specify this in our URL when we make the request to the servlet. We write that to the account number container. We link to the target program. I do need to pass the channel in here. We'll do that in a second. We'll link to the target program, and then we'll read the account balance from the channel, which the backing program will have written to that channel. And then we'll get that in a string and return this account response. And Liberty will actually handle turning this into a JSON document for us. So the first thing we need to do, this is a Maven project. This pom.xml here is where I declare all my dependencies. So you can see I have a dependency on some of the Java EE APIs to let me declare that servlet here. I am going to add some dependencies to this to make the JCICS API available to it. So I have a snippet here. We're going to use this dependency, which is on the com.ibn.cics.server jar. Now, one of the really neat things about Eclipse, and this is actually true of a number of IDEs, is Eclipse has really good Maven integration. So Eclipse knows that this is a Maven project. It means that once I add this dependency here, Eclipse will notice that I've added this dependency, and it will interact with Maven to work out that it's been added to the class path so that my local compilation in Eclipse just works. So if I look at my servlet now, you can see that a lot of my errors that I had have gone away. I actually have a clean compile now. I do need to remember that when I link, I have to pass the channel. So let me update that. So having done that, I would be able to successfully build my application now, but I still haven't done the part where I take this. So this is still a raw Java enterprise application. I still need to build a CICS bundle to put that in. So to do that, we need to use our new CICS bundle Maven plugin, and this is how we declare that here. I'm just going to copy this and put it in my pom.xml. So there's a separate section for dependencies here, and underneath you have a build section, and this is where you declare your build extensions. So we're going to use our CICS bundle build extension here. And all we're saying here is that we'd like to run the CICS bundle Maven plugin, and we have to specify which JVM server our application needs to be deployed into. So we can specify that here. You can use properties in Maven build, so you'll be able to script this and have a version of this that you can substitute. Once I've done this, I can, because Eclipse has got Maven integration, I can use Maven to run this build. So I'm going to run a Maven install here. And now this build is really useful, because what it's going to do is it's going to run the regular Maven build for my Java application, and then on the end of it, it's also going to run a the CICS bundle Maven plugin to turn it into a CICS bundle. So if I look in the target directory, this is where Maven puts its build output. I get this .war file, which is my Java web application, and I also get this CICS bundle zip file here as well. And this is where we've taken that war application and wrapped it in a CICS bundle. So if I expand this, you'll see that I get, if I open this with the text editor, so you can see that I get the same CICS.xml file that I would have got if I authored that in CICS Explorer. I get the war file included in my CICS bundle, and I get this .war bundle file, which if I open that, you'll see it's written the JVM server name into there. So this is exactly the same as what we would have done in CICS Explorer, except instead of doing it, configuring everything so that it's easy to do from a UI manual tool point of view, we now have an automated process for building this Java application and building the CICS bundle for it to go into. So I'm going to hop back to the slides quickly now. So our JCICS application, which we have here, in order to try it out, ordinarily, we would have to deploy that Java application to a CICS region. So normally you'd be using CICS Explorer to do that. You can right click on your CICS bundle and run the export to ZOS Unix file system, and then you can go find your bundle definition and lifecycle that to make the bundle available in your CICS region, and then you'll be able to try out your servlet. So you'll be able to make a web request against that servlet and see how it works. The turnaround time on that can be off-putting from the point of view of trying to make application changes, experiment with them, and see how they work. And one of the requests we've had from customers over the past few years is there not a way, so Java applications are really interesting because they are write once, run anywhere. So the idea is that you write your Java application, you compile it into Java bytecode, which is the binary form of a Java application. And then that Java bytecode is portable. So you can take that bytecode, you can run it on your local, like my laptop here, I could run it on, or I could take it and run it in CICS, or I could run it on an x86 server, and the Java application would behave the same. Obviously, if it has dependencies on things like the JCICS API jar, they're not going to be, or the JCICS API, they're not necessarily going to be available in all environments. So the main problem you'll have with trying to run a CICS Java application on your laptop is the second it tries to make a JCICS API call to invoke another program, the whole back-end services that it might rely on are not going to be available to me locally. So in the past, deploying the application to CICS has been the only way to try it out, but that was something that we wanted to change for CICS TS56. So we wanted to give developers the flexibility to be able to write their Java applications and then preserve some of the development experience they might be used to with Java, where they can try out their application locally before deploying it to a real environment. So in order to do that, we wanted to get the JCICS API so that you could use it locally as if you were running in CICS. And this is a kind of simulation for development purposes only. The way we did that is we developed an extension of the JCICS API called JCICS. And the way JCICS works is you can write the same Java application to this slightly different API called JCICS, and then you can still deploy that application unchanged to a CICS region that will run there. So the application doesn't have to be changed to deploy, but you have the flexibility of being able to run that Java application locally. And it's just a case of how you configure it to run. So you can set that application up so that when you run your application, when it tries to link to a CICS program, you configure your environment to tell it which CICS region you'd like to back that link. So you point it at a remote CICS region, which has the program you're trying to link to in it. And then when you run the link, it will invoke the remote program, and it will write any data it needs to containers in a channel in the remote region, and it will return when the backend program writes its response to containers in a channel, our local running application in my development environment will be able to read data from those remote containers in the remote channel using this magic transport that we have. So I would say as a caveat that this is brand new for us. We don't support this kind of remote behavior for the entirety of what you might be familiar with in the JCICS API for this JCICS. At the moment, we only support linking to programs using channels and containers, so you can't do things like COM area just yet. But that is something we'd like to look at in the future. So if that's interesting to you, and if you have any other kind of things you'd like to be able to do remotely that you're not able to currently, please let us know, and that can help inform where we spend time in the future on improving this. So I mentioned that when you deploy the application, it's just a case of, when you run the application, it's just a case of how it's configured to run that determines the behavior. So we have this JCICS API. There are two different implementations of the JCICS API. There's a native implementation that runs in a CICS region, and that's the yellow area. When you run with the native implementation, that's actually backed by exactly the same JCICS jar that you'd have used in the past. It has the same performance characteristics as JCICS. It's just a very thin Java layer on top of JCICS. That means when you try and use the JCICS API, it behaves exactly the same way as it did before. When you run your application locally, we actually use an HTTP transport against, and we forward your link, your exec-CICS, essentially your exec-CICS API requests. We forward them so they run against the remote CICS region over a proprietary HTTP transport. So you have to configure a server that's going to run in your target CICS region that's going to host that API. And I'll show you a little snippet of how that works in a minute. Once you've done that, then you can take your Java program and run it locally using the HTTP client. And if you're happy with the way your application works locally, you can take that application and deploy it unchanged to a CICS region. Because the CICS region's environment is configured differently, the JCICS APIs will run natively there instead. So you get kind of flexibility without having to make application changes to make it run locally. So this is, so the HTTP API is actually hosted by a Liberty server running in your CICS region. So this, when you configure your CICS region, you have to set up a Liberty server. And in that Liberty server, you have to enable our new feature here, which is this CICS JCICS Server 1.0 feature. And that enables that region to be a target for remote development. There are some security options you can configure there. For the purposes of this demonstration, we're using the JCICS API unauthenticated, but you can set that up authenticated and using SSL, etc. as well. From the client point of view, this remote development, we've only thus far been working on client support in a Liberty environment as well. So that's convenient for our demo where we're looking at a servlet application. What we're going to do is, as well as running a Liberty server in CICS, we're going to run a Liberty server locally in my development environment as well. In that Liberty server, we're going to add this JCICS client 1.0 feature, and then we specify this additional bit of configuration here where we point it at the HTTP API that's being served by the target CICS region. So that's the port from the previous server config. So we have two Liberty servers, one running in CICS and one running on my laptop. And what we're going to do is deploy our JCICS application into my local Liberty, and it's going to run against the remote backing accounts program using the JCICS API for the transport. So back over to Eclipse. In order to do that, the first thing we need to do is change our application so that instead of using the JCICS API, it's going to use JCICS. So this library is available on Maven Central as well. We just have to change the server to JCICS here, and then instead of compiling our application against the JCICS API, it's going to be compiled against JCICS. Now you'll notice that my account servlet's got some compile errors in it. If I come over to it here, that's because all of these references to types are in the JCICS API, not the new JCICS API. So I'm going to go through the process of converting this JCICS program to a JCICS program now. So the analog that we have for task in the JCICS API is called CICS context, but it performs much the same role. So we're going to assign that in a constructor here. So now we don't need task. Instead of having a representation of the program we're going to link to, the way the JCICS API works is we take this context and we create an object that's capable of linking to a target program using a channel. So we're going to use this constructor here for that. It creates an object called a channel program linker, but it performs much the same role as program would in the JCICS API. We are going to specify the program name and the channel name. So we have both of those pieces of information here already. So let me fill those in. So the program name is this accounts, so we can put that in, and the channel name is this accounts channel here, and we can put that in. Now we can delete these bits. Now we are going to set some input. So there are some sugar methods for setting string input on containers very quickly. So this set string input method here we're going to use to set the account number. So we put the account number container name in the first argument, and then the value from our input here from our servlet into the second parameter. And once we're done with that, we can call the link method. Now, because we set this up to use a channel, we don't actually have to pass the channel into our linker anymore. Once we've done that, if I assign this to a local variable so we can see what response we actually get a response object back, and that's actually going to let us work with the containers that were written to by the backing program. So we're going to use that response to read the balance out of the backing channel. So if we use response dot get string output instead of set string input to read the account balance, assign that to a local variable, which is going to be balance, and then we're going to return our response object with the balance in. This exception, actually, the CICS got uppercased in it in the newer API. So once that's done, my application's been converted so that it will run successfully with JCICS, and now we're going to look at what I need to do to run it locally. So I'm not going to go through the whole process of setting up a Liberty server locally to do that. I just want to show you the experience you get. To achieve that, I've scripted in this snippet here how to install Liberty and how to install our custom JCICS client feature into it, and how to deploy the application so I can have like a one-click experience for running that. So I've set up a launch config for that. That's this dev config here. If I run that, what's going to happen is my Maven build here is going to download WebSphere Liberty profile, install that locally, build my Java application, build my Java application, and then take that Java application and run it in that Liberty profile server. And it's also going to configure that server to be targeting the remote CICS region as well. So once that's run, I'll get this message saying that my application is available locally. If I go over to my web browser here, this is going to be pointing at my local server. And if I run this, whoops. If I fix it so that it works properly. This is actually one of the advantages of running locally, is when you make a mistake like that, you can easily correct it and then try rerunning the application without having to go through the whole redeployment process. So ordinarily what might have happened there, this was not a planned part of the demo, but ordinarily what might have happened is I would have deployed that to CICS, I'd have run the application, I'd have got an error, I've had to look at the Liberty server log, find out what happened, make a change to my application and go through the whole bundle deploy process again. Because I can round trip on these changes locally, I can fix that and work out that I made a silly mistake much faster. So this balance that we're seeing here in the response is actually coming from a backend CICS program running in a CICS region on Z, but this front end servlet is actually running on my laptop here. So there are, because it's running locally, you get a whole bunch of other flexibility as well, like being able to debug the application. So I can connect a debugger to this and step through the code. I'm not going to show you that now so that I can show you some of the other bits and pieces we've been working on. So the next thing I want to do with this application is deploy it to a real CICS region. I said that JCICS applications can be deployed unchanged. The existing way of doing that would be to use CICS Explorer and go through this bundle deployment process, which means, and the unfortunate thing about the bundle deploy process is that it does expose developers to a lot of the mechanics about how CICS bundles work. So if you've deployed a CICS bundle before, you have to know where on HFS the CICS bundle is going to go. You right-click in CICS Explorer, you export your CICS bundle, you pick the destination. Explorer has to have a separate FTP connection that it uses to write that bundle to the file system. And then you have to know which of the bundle resources you're working with in CICS Explorer. And you have to go around in there, find the target CICS bundle definition and install it if it's not already installed. If it is already installed, you have to disable it and enable it, and maybe even discard and reinstall it, depending on what changes you've made to your CICS bundle to get CICS to reread it. And you have to do that every time you've deployed your application. It's quite a involved process to have to repeat. So in order to make that easier, what we've introduced, instead of having to have a separate FTP connection, is a managed bundles API that's served out of CPSM. So this is available in CPSM, running in CICS TS 5.6. And the way that API works is instead of exposing the tooling to the CICS side of things for how CICS needs to work with CICS bundles, we make an HTTP API endpoint that can handle that for you. And then in a variety of front-end tooling, be it a Maven automated build or a Gradle automated build or whatever, you can push a CICS bundle at this HTTP endpoint, and that's running as a managed service can be responsible for what you need to do to make that bundle available in your CICS region so you can round trip on changes quickly. There are a few advantages to this way of doing it as well. Because we have one entry point for writing bundles to the system, we don't need to give developers access to writing to ZFS. If you notice at the bottom, instead of running as the developer's ID, once we push the bundle to this API, which is hosted in CMCI, we hand over to a functional ID, a deploy user, and that's actually going to be responsible for writing the bundle to ZFS. So you don't have to give developers write permission to ZFS. Because you have this single entry point into the system, it allows you to wrap some governance around this as well. So you can look at, you can potentially, we don't support this yet, but the sort of thing you might be able to do is write an extension that looks at that bundle and says, this bundle's okay, and then looks at another bundle and says, this bundle's bad because the value of this attribute is wrong, or the content of the bundle is bad, or whichever. Then the rest of the other nice thing about this API is it will handle life cycling the bundle for you. So once it's written it to ZFS, it will tell your backend CICS region that it needs to go and make that bundle available, which will make the CICS bundle look at the CSD, work out where the bundle is, read it from ZFS, and then load that bundle into your CICS region. And the API will manage whether or not, how much of the disabling and discarding process needs to happen, and waiting for that to complete before it returns a response to you. That's another one of the frustrations about the bundle deploy process, is once you've enabled your bundle, that's actually an asynchronous process, and you have to wait a bit until all of your applications are started before they'll be available. And this API actually waits for that to happen before it tells you that everything completed successfully. So the last thing we're going to do in our demo is take this Java application and use the Manage Bundles API to deploy it to my target CICS region. So in order to do that, that's actually support that's provided by this CICS bundle Maven plugin again. I have to provide a little bit more configuration, which is here. The first thing we need to do is tell it that in addition to producing this, in addition to bundling my application, we want to deploy it as well. So we're going to add support for the deploy goal. And then we need to provide these extra parameters as well. This part of the process is authenticated. There's no way to disable this authentication because we're doing this context switch to a functional ID. So that mandates us to have security turned on for this, which is why I'm not showing you a simpler path. But again, we do support authentication for this. We have to, in fact. And you specify a URL here. This is actually the URL for the CMCI endpoint. So this is exactly the same one you put in when you're connecting in CICS Explorer. You supply your user ID that you're going to use and your password. Then you still need to have a bundle definition created for you in your CSD. So you have to specify the name of the CSD group you're using and the name of the bundle definition you're using. And then you have to specify the name of a CICSplex and the name of a CICS region that you're going to be targeting for that. Once you specify these properties, then it should be possible for me to use this Maven build to have one build which compiles my Java application, puts it into a CICS bundle, and deploys that CICS bundle to a CICS region and waits for it to become enabled. So that's going to be this build here, which I have pre-configured. If I run this, it's actually going to prompt me for my username and password. So you'll be able to see from the build log at the bottom, the first thing we do is we go away and we build our Java application. Then we're going to wrap that in a CICS bundle. Once that's been wrapped in a CICS bundle, we're going to use the bundle deploy endpoint to push that into a CICS region. So what it's going to do is it's going to find any previously installed version of that application, disable it, and wait for that to happen, discard it, wait for that to happen. Once the application's been discarded, it will then go onto ZFS, clear up the bundle directory, so delete any previously deployed bundle, unpack the new bundle to that location, and then go through the process of installing and enabling the application and waiting for it to become ready. This actually took a little bit longer than normal. The normal deploy time is about 4 seconds, so there's obviously something running a little bit slow on our system at the moment, but the bundle is still deployed successfully. If I go to my second tab here, and look at this, this is going to be exactly the same application, but instead of running locally in my web browser, it's going to be running in my CICS region instead. This also seems to be running a little bit slowly. So you can see we have exactly the same application deployed to CICS as well. So you get for Maven and Gradle developers, you get this benefit of being able to try your changes out locally. You actually get that if you're using CICS Explorer as well. The JCICS API is available locally, whatever you're doing. But for Maven and Gradle developers, you can also use this in build system kind of enhancement. So you actually don't need CICS Explorer at all anymore. And that is also interesting, the fact that you don't need CICS Explorer anymore, because it liberates developers from having to use the versions of Eclipse that we support for application development. So you can use this tooling in any development environment that supports either Maven or Gradle. So we have a variety of demos that we'll run through. You can do, this is an example of doing CICS Java application development using the IntelliJ IDE, which is probably the most popular Java IDE at the moment. And previously it wasn't possible to use it for CICS Java development at all, really, because you couldn't write CICS bundles. Now, because IntelliJ has really good Gradle support, you can use our Gradle tooling in IntelliJ and have a kind of integrated development experience for all of that. VS Code has extensions for Maven and Gradle, so you'll be able to take the experience you get from those plugins and run it in VS Code if you want to use that tooling instead. I've actually done a demo before using Eclipse Che. So Eclipse Che is the fork of VS Code that runs as a hosted web service. So you can do CICS Java application development in a web browser without having to have any client install at all, which I think is really interesting for the future. And it's kind of, we didn't plan to target any of these environments specifically, but because they all support the tool chains, the way of describing the way a Java application is built, then if we deliver our tooling in those environments, then it increases the options that Java developers have there. So I know I'm a little tight on time here, so I think I'm probably going to wrap it up there. There is a bit more material in the slides if anyone's interested about how we manage transactions for the remote API, but suffice it to say that your behavior of your transaction in terms of like what is contained within your transaction should be the same for JCICS, regardless of whether you're running locally or remotely. So do we have time for any questions, Rob?
We do. If anyone's got any questions, I'll look in the chat. Okay, I can't see anybody typing anything, Stu. So I think we're okay unless you've got any closing remarks to make.
No, that's great. If anyone does have any questions afterwards, my LinkedIn profile is on the GSE speaker profile, so you can go look me up there and send me messages on there if you're interested. And we're always happy to do kind of one-on-one calls and talk more in detail about the different technologies that we're looking at here as well.
Okay, well, thank you very much. You certainly made it look very smooth and easy to do. I must admit, my coding in this area is not too hot, so lots to learn for me. But thank you very much for the presentation, and best of luck with everything you're developing at the moment.
Yeah, we're working on a tutorial at the moment that's going to go on IBM Developer, which is going to contain a kind of walkthrough of the scenario that we're looking at in this demo that I did here. So if you are interested in having a play with it, then keep your eyes peeled on developer.ibm.com, and we'll have something there in the near future.
Okay, thanks very much.
Have you got the feedback slide there, Stu?
Yes, I do.
So feedback is important to us, so please could you put your feedback in?
Yeah, all feedback gratefully received, everyone. It's important for next time. We're trying to get that they glean the experiences of this virtual conference. From my point of view, it looks like we're reaching out to a lot more numbers, which is a really good thing, considering our platform and perhaps we don't have as many people going to CICS GSE as we did many years ago. So I'm quite enthused by the numbers and people turning up. And obviously, if we get a chance to do it again next year, we're relying on that feedback in order to justify to be able to do that. So all feedback is really appreciated. We're back on again, the next one at 1:30 with Will Yates, and might be a challenge to some of you. It's not new in CICS, but it might be new to you. So if you think there's anything that you might not know about in CICS, I'm sure you all know everything. Come along and listen to Will I'm sure there's a bit of innovation in whatever he's trying to do. Okay, thanks for your time, everyone, and see you again at 1:30. Cheers.
Thanks, everybody.